sounds deceptively simple.
A product leader walks in with a slide that says, "We can plug this copilot into our stack in a week. No need to build models ourselves." Around the table, operations sees efficiency, finance sees a fast path to value, and engineering sees fewer models to maintain.
The only thing between your organization and a big leap in capability is a contract, an application programming interface (API) key, and a bit of integration work.
What nobody can quite answer in that moment is the quieter question underneath. When this external artificial intelligence (AI) system behaves badly, who actually owns the blast radius? You are listening to a Wednesday headline feature from Bare Metal Cyber magazine, developed by Bare Metal Cyber.
The piece is called Model Supply Chain Mayhem: Securing the AI You Didn't Build Yourself. It is about the reality that most organizations will consume far more AI than they will ever build. They will rely on opaque third-party models, as-a-service copilots, and integrations that hide entire model supply chains behind a single endpoint. On paper, vendors have all the right words: secure, compliant, responsible. In practice, you are routing sensitive data, business processes, and customer trust through a black box whose training data, evaluation methods, and change control you do not really control. For Chief Information Security Officers, technology leaders, and senior engineers, the real challenge over the next few years is not learning every algorithmic nuance. It is becoming a supply chain strategist for AI you did not design. That means treating external models less like magical utilities and more like complex, high-risk suppliers that sit deep in your critical paths. From here, we walk that decision forward. We start at the moment you are asked to turn an external copilot on, then move backward into model lineage and governance, and finally out into the operating model you will need if you want to live with these systems without being surprised by them every week. The easiest trap for leaders is to treat external AI like any other cloud feature and quietly think, it is their model, their problem. On organization charts and contracts, that sounds plausible. In the real world, your customers, regulators, and internal stakeholders do not care who tuned the large language model, LLM, or whose logo is on the portal. When a co-pilot hallucinates a compliance violation into a customer email, leaks sensitive deal data into its suggestions, or quietly changes behavior after a model update, the reputational and regulatory fallout lands on you, not on the vendor's website. You see the accountability gap first in how people talk. Product teams talk about consuming a model. Procurement talks about subscribing to a service. Security is left trying to retrofit a vendor risk process that was built for storage, payroll, and traditional software, not for probabilistic engines that learn, drift, and respond differently as context shifts. Nobody is quite saying, this external AI is now part of our critical path, but behavior gives that away. Developers wire the model into customer-facing workflows. Analysts put it in front of sensitive data. Executives mention it on earnings calls. At that point, you effectively co-own its failure modes, whether or not the contract admits it. For security and technology leaders, the shift is mental before it is technical. You have to assume that any AI model embedded in your processes is now part of your safety case, just like a payment processor or an identity provider. The old escape hatches, like the vendor is certified, or legal sign the terms, or we followed the reference architecture, are no longer defensible on their own. The work becomes defining where your responsibility starts. That includes what guardrails you wrap around the model, what categories of data you will allow it to see, which workflows require additional approvals before AI is allowed to act, and how you will respond when, not if, the system misbehaves in production under your name. When teams say, We just call the model via an API. They are flattening an entire supply chain into a single verb. Under that abstraction sits a stack of dependencies that looks more like a modern software bill of materials, SBOM, than a neat client-server diagram. There may be a foundation model hosted by a hyperscale cloud provider, a fine-tuning layer run by a niche startup, a specialized safety or guardrail service from a third party, and an integration platform your own engineers built. Each element has its own data flows, its own logs, its own change cadence, and its own incentives. From a risk perspective, every box in that chain is a potential point of failure or data leakage, even if your teams never see it directly. Your first job as a leader is to turn that invisible supply chain into something you can actually reason about. You do not need to recite model architectures, but you do need a minimum viable map. That map should tell you whose infrastructure hosts the model, who owns the training and fine-tuning, which upstream providers are involved, where prompts and outputs are stored, and which internal systems sit upstream and downstream of the AI. In a typical deployment, you may discover that a simple copilot touchpoint actually threads through chat interfaces, orchestration layers, prompt libraries, policy engines, and data connectors, each with different owners and logging practices. Until that map exists, most control and risk conversations are theater. Once the supply chain is visible, patterns emerge that you can actually manage. You can distinguish between models that sit behind your own network and identity controls and those that live entirely in external environments. You can separate low-risk, low-sensitivity uses from flows that cross regulated boundaries or touch critical decision-making. You can see where a single upstream provider is a concentration risk because multiple internal products quietly depend on the same foundation model. Most importantly, you can start asking sharper questions. Which of these links can we segment, instrument, or replace, and which ones are we implicitly betting the company on every time we send a prompt? When you accept that external AI is now part of your critical path, the failure modes start to look familiar and then a little stranger. One category is training and fine-tuning data exposure. A model that has been tuned on support transcripts or code snippets from many customers can surface patterns or phrases that were never meant to cross organizational boundaries. Even if a vendor swears they keep tenants separate, the combination of few-shot prompting, retrieval mechanisms, and subtle configuration mistakes can cause the model to remember more than it should. When that memory shows up as a suggestion or answer in your environment, nobody outside your company will care that the root cause was a misconfigured upstream vector store. Prompt injection and output manipulation form another class of failures that are easy to underestimate. Your teams may be careful about how they construct prompts, but they do not control what the model has been trained to prioritize or how upstream safety layers interpret hostile content. Imagine a public sector agency using an external model to summarize citizen submissions. Adversarial or manipulative inputs can steer the model around safety filters, producing biased, misleading, or inflammatory output that now appears under an official letterhead. The agency's name is on the letter that goes to the public. The vendor's internal red team is not present in the room when the criticism or regulatory interest arrives. Then there are the quiet behavior changes and upstream outages. A regulated bank embedding an AI copilot into internal tooling may see answer patterns shift overnight when the upstream provider rolls out a new version, changes content filters, or rebalances cost and latency. That shift can break carefully tuned workflows, invalidate prior validation work, or create inconsistent advice across regions and business units. A software as a service, SaaS, Vendor building AI features into their product may suffer cascading outages when an upstream AI gateway struggles under load, even though every internal microservice is technically healthy. In both cases, leaders discover that they own the impact but have little influence over the change calendar that caused it. If you treat external AI as a static dependency, you will be surprised again and again by a dynamic system you never fully see. Most organizations already have some flavor of vendor risk management and software supply chain review. The problem is that these processes were built for payroll systems and storage buckets, not for probabilistic engines whose output is behavior, not a fixed feature list. If you send an AI vendor the same old questionnaire you use for human resources platforms, you will get comforting answers that miss the point. Leaders need to adapt due diligence so it interrogates the things that make models different: training data, evaluation practices, change control, and the way the provider thinks about incidents where the bug is what the system said or did, not a simple code defect. A useful starting point is model lineage. Here, you want to understand which foundation model underpins the service, who operates it, how it was trained, and what fine-tuning or reinforcement layers have been added on top. This does not mean demanding source code. It does mean asking concrete questions. What categories of data were used for training and for fine-tuning? What guardrails are applied and how are they updated? How does the provider handle removal of problematic data? What happens if a regulator or a customer demands that specific categories of data be excluded from training or responses? For sensitive use cases, this extends to independent evaluation. Has the model been tested against your threat models, your high-risk prompts, and your domain-specific risks? Or are you relying entirely on the vendor's generic benchmarks? Contracts and service-level agreements are where good intentions either gain teeth or evaporate. Generic uptime commitments are not enough when the real risk is harmful, inconsistent, or biased output. You should be negotiating for commitments around transparency of model changes, notification windows for significant updates, access to logs or evaluation summaries that describe behavior, and clear roles in incident response when the model misbehaves in your environment. The goal is not to force AI vendors into old software molds. The goal is to make explicit who does what when things go wrong, so you are not improvising when a regulator asks who knew what and when. Leaders who do well here are the ones who stop treating AI due diligence as a checklist and start treating it as an ongoing dialogue about behavior, not just infrastructure. Even if you extract better transparency from vendors, you will rarely get full visibility into how an external model works. That is the uncomfortable reality of today's AI ecosystem. The practical move is to assume that the model is a black box and build your own trust instrumentation around it. That starts with isolation. Instead of wiring a model directly into core transaction flows, you place it behind clear boundaries. Those might be dedicated integration services, tightly scoped network paths, and identity-aware gateways that control who and what can call the model. The aim is simple. The model should never be the only thing standing between an untrusted input and a critical action. The next layer is input and output control. On the way in, you can normalize and constrain prompts. You can strip or tag sensitive data, enforce length and format limits, and add contextual markers that your own policy engines can reason about. On the way out, you can route outputs through filters, validators, and sanity checks that reflect your business rules rather than the vendor's generic safety settings. For a cloud-native SaaS company, that might mean schema validation and business logic enforcement before an AI-generated change is applied.
For a healthcare provider, it might mean human-in-the-loop review and policy checks before any AI-generated text leaves the organization under a clinician's name or signature. You also need observability and control that presume drift and failure. That includes logging prompts and outputs at the right level of detail, replaying traffic to test new model versions or guardrails, and running periodic evaluations against your own high-risk scenarios instead of relying on vendor demos. It means having real kill switches that product and operations teams know how to trigger and are empowered to use. An external copilot that can be disabled, rerouted, or downgraded in minutes is far less dangerous than one that is woven so tightly into the application that any change requires a full project. Leaders do not have to make black boxes transparent, but they do have to surround them with enough structure that when behavior shifts, the organization sees it quickly and can respond with something more robust than hope. At some point, AI supply chain risk stops being a project and starts being part of how your organization runs. That shift does not happen by accident. If AI ownership is scattered across innovation teams, data science, and a handful of enthusiastic engineers, you will get bright spots and policy slide decks, but not a working operating model. The practical question becomes, who owns the risk of external AI models end-to-end, from vendor selection to decommissioning, and how do they coordinate everyone else? In many organizations, that responsibility will land with a partnership between security, a central AI or data function, and procurement, backed by legal and compliance. The operating model needs clear stages that map to real decisions, not just high-level governance slogans. One way to think about it is in loops. There is an intake loop, where new AI use cases are proposed and triaged based on sensitivity and how much they rely on external models. There is an evaluation loop, where security, data, and legal apply the kind of model-specific due diligence we have discussed and decide what conditions must be met for launch. There is a runtime loop, where monitoring, incident response, and change management keep an eye on behavior as the vendor and internal usage evolve. And there is a sunset loop, where models or vendors are retired with deliberate attention to data retention, logs, and downstream dependencies that might still assume the model exists. Maturity here is less about grand frameworks and more about repeatable conversations. In a more advanced organization, product managers know to flag external AI dependencies early, and they know roughly what that will trigger. Procurement has standard clauses and playbooks ready for AI vendors. Legal understands the difference between infrastructure risk and behavior risk and can tune language accordingly. Security can speak fluently about model lineage, data flows, and evaluations without needing to sit in every meeting. The CISO and other technology leaders set the tone by insisting that external AI is treated as a critical supply chain, not a toy feature, and by backing teams when they say no or not yet to risky integrations. Over time, that operating model becomes a competitive advantage because you can say yes to powerful AI capabilities faster and more safely. At its heart, this whole topic is about accepting that when you route your business through external AI, you inherit its behavior as your own. That initial decision in the conference room to plug in a powerful copilot or model you did not build is no longer just a procurement question or an architecture choice. It is a commitment to live with the quirks, drift, outages, and edge cases of someone else's system in front of your customers and regulators. Once leaders see it that way, the conversation shifts from "can we turn it on?" to "how do we live with this responsibly over the long term?" Closing that gap means weaving several threads together. You make the invisible supply chain visible enough to manage, so we just call an API becomes a real map of dependencies. You update due diligence so it interrogates model lineage, behavior, and change management, not just data centers and certificates. You build a control layer around black boxes that assumes drift and failure instead of assuming that vendor safeguards are enough. And you stand up an operating model where security, data, legal, and procurement know their roles, so each new AI integration feels like a repeatable pattern, not a fresh gamble. For CISOs and technology leaders, the payoff is strategic. You can say yes to external AI faster and more confidently because you are honest about the risks and intentional about the controls. The next time a team pitches a game-changing copilot or model, the discussion can start from stronger questions. What happens to us when this upstream system fails in strange, non-obvious ways, not just when it goes down loudly? How will we see that behavior? How will we contain it? And how will we explain it to customers, boards, and regulators when we have to? Those are the conversations that turn model supply chain mayhem into something your organization can harness instead of fear. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.